All right, for 10, the vertical asymptotes, that's where you set the denominator equal to 0 to find what the vertical asymptotes are. It's okay if you just wrote that once. I wrote it for each. So x equals 2. When you factor, you get 1/2 and 4. That's fine. Okay? And then the horizontal. What did I underline here? Degree. So when you are explaining for the horizontal, you have to make sure that you said something about the degree. If you didn't, please add that in now. Okay, because if you missed that part on your quiz, then we're going to have to replay this video so you can hear me saying it again. Alright, so when the degrees are equal, it's the fraction formed by the leading coefficients. Okay, when the degree of the numerator is less than the degree of the denominator, it's y equals 0. Okay, and then for number 11, there's no x-intercept. It's not 81, it's not 0. If you set this equal, there's nothing to solve for, that's no x-intercept. The y-intercept here, you plug in 0, you get 81 over negative 16. That's what it is. 0, negative 81 over 16. If you wrote it as a decimal, it's okay. Okay, and then for 3, your vertical asymptotes are x equals 2 and x equals negative 2. And then the horizontal is y equals 0. Again, that's where the numerator degree is less than the one on the bottom. Okay, and then here is your graph. Okay, so remember, you are going to have to find your max value. Okay, when you find your max value, sometimes it's really close to the y-intercept. Sometimes it is the exact y-intercept. Okay, but you can't just assume that it is. You're going to have to find your max value. What's that? Why keep it as 5? Oh. Yeah, we're going to want to round. Just double check that. When I did mine, it was negative 5.06. Okay. Okay, and then, yeah, so make sure that you are doing the calc. So like when I did this, I got this exactly. Well, not, I mean, I got this number. Okay, so, also, when you're finding the zeros of the denominator, a couple people ask me this because you do get this. Imaginary asymptotes are not on the graph. So if you have anything that's imaginary, it's not real, it's not on your graph. Okay? Alright, let's go to the next one. Okay, so for B, the x-intercepts. When you're doing the x-intercepts, it's the zeros of the numerator. So when I solved, I subtracted 6, divided by 3, but then when I go to find this, again, I have something imaginary. If you ever get something imaginary, it's not on the graph. So there are actually no x-intercepts here. Okay? So if you got the plus or minus I root 2, again, it's just no imaginary values. The y-intercept, you plug in x is 0. So 0 plus 6 over negative 3, 0 minus 3, okay, is going to be negative 2. Guess where else you could verify that? The table. Just go to the table, right? Because you can plug in 0 and see what it is. That's fine, okay? All right, and then the zeros of the denominator are negative 1 and 3. Any asymptote has to have your x equals because it's a line. The horizontal is going to be y equals 3 because the degrees are the same. If they're equal, leading coefficients, simplify. Okay, now, this is one that we talked about in our notes. Do you guys remember what I told you about this guy here? See how this dips below the asymptote? So I need you to check this. If you put y is greater than 3, okay, what we have to do is we have to check in this window here and make sure that it doesn't dip under. So how can I do that? How can I check to see if it goes under or not? Yeah, you can find the minimum value. You can tell your calculator to find the lowest point. And if it's above your asymptote here, then you know that you're good. But if you tell it to find the lowest point when it's below there, you have to find that minimum value. Okay? And then this is what we talked about. Y is less than or equal to the max, or y is greater than or equal to the min. And then I said the left branch because it's this guy here. Okay? All right. And I'll plug that into my calculator. Do you guys want to do that together, how to find the minimum? All right. So the explanation is the function has a slant asymptote when the degree is exactly one more than the degree of the denominator, okay? This one was a little bit harder because this number here was what? This is one you can do with your calculator. Guess what? You aren't going to use your calculator. What made this one a little bit more difficult? And I would do this if I would put my placeholders in here. Because you had a fraction, right? What do you multiply by 2 to get to 1? 1/2. So 1/2 x. So a half times 2 would be x cubed. 1/2 times x. Hey, guys, I need you with me. Again, it's okay if you don't want to listen. I can't make you listen, but I need you to be quiet so others can. Okay, and then negative 1/2 x here. Now, do not forget to change your signs, because that is going to affect what you have here. So this is negative 1/2 x squared. This is 1/2 x. This is plus 4. Now, if you're having trouble doing that in your head, don't worry. You're dividing, right? So can't we just do negative 1/2 divided by 2? Yeah. Skip, flip, multiply. So it's negative 1/4. Okay, so negative 1/4 times 2 is negative 2/4, which is negative 1/2. Negative 1/4 times x is negative 1/4 x plus 1/4. Okay, if you can do this one, then you'll be able to do the one on your quiz, okay? Okay, so 1/2 plus 1/4. 1/2 is just 2/4, so this is going to be 3/4 x. Okay, already I know what? (16 minus 1 is 15). Already I know that this degree is less than, so that's how I know when to stop. When you write your slant asymptote, don't forget your y equals. You need your y equals because it's a what? A line. So the form of your slant asymptote is y equals the quotient. They should always be linear. If you have something that's x squared, that's not correct. Okay? Alright. So I will see you guys Monday, and then as soon as you guys come in, I will get you started, okay? If you get yourself ready, okay?